the invisible process that changed how humans eat. It didn't arrive as a revolution. No announcement, no dramatic shift in taste or tradition, just a quiet chemical process that slowly rewrote how food reached every table. At the time, nothing about it felt transformative. Meals still looked familiar. Recipes remained recognizable. Cultural traditions around food continued uninterrupted. The change did not announce itself through flavor or ritual, but through absence, specifically the absence of urgency. Food no longer demanded immediate consumption. Time loosened its grip, and with that loosening, an entirely new relationship between humans and nourishment began to form. For most of history, eating was constrained by chemistry. Food spoiled quickly. Seasons dictated survival. Preservation methods existed, but they were fragile, inconsistent, and highly local. Drying, salting, fermenting, and smoking worked only within narrow limits. Chemistry set strict boundaries on what humans could store, trade, and rely on. Hunger was not just a social problem. It was a chemical one. Survival depended on understanding decay, anticipating it, and working around it with limited tools. To understand why this process matters today, we need to return to that constraint. For much of human existence, decay was the dominant force shaping diets. Microorganisms followed simple rules. Given time, moisture, and warmth, food broke down. Chemistry decided when nourishment turned into waste. Entire societies were built around managing that countdown. Daily life revolved around preparation, preservation, and timing because chemistry allowed no shortcuts. Then a process emerged that changed balance, not by stopping decay entirely, but by slowing it just enough. Reactions were interrupted. Microbial growth was delayed. Enzymatic activity was restrained. Time itself felt stretched, not halted, but negotiated. Food no longer existed on a strict clock. It entered a gray zone where edibility lingered beyond what biology once allowed. At first, the impact seemed modest. Food lasted longer. Transport became feasible over greater distances. Surpluses appeared where scarcity once ruled. What previously spoiled in days now survived weeks. The process felt like progress without trade-offs, an improvement that solved a practical problem, without altering anything fundamental. People did not need to rethink eating. They simply benefited from it. But chemistry never works in isolation. Altering one reaction reshapes others. By slowing decay, the process also changed how food was produced, stored, distributed, and ultimately consumed. Habits shifted subtly. Systems adapted quickly. What began as preservation became infrastructure, and infrastructure, once built, reshapes behavior without asking permission. This is where the story truly begins, with an invisible chemical process that didn't just protect food from spoilage, but quietly redefined what eating meant for humanity. As the process spread, it reshaped food systems far beyond preservation alone. Longer shelf life altered priorities. Speed mattered less. Distance mattered less. Food no longer needed to be consumed near where it was grown. The link between land and plate weakened. Geography loosened its influence on diet, replaced by chemistry's ability to delay time. Chemistry had inserted itself between harvest and hunger. Natural reactions that once unfolded predictably were paused, slowed, or redirected. Microbial ecosystems were restrained. Enzymes lost momentum. Decay became negotiable rather than inevitable. What had once been a biological certainty became a variable to manage. At first, this flexibility felt like freedom. Cities expanded without fear of immediate shortages. Trade networks stretched across continents. Diets diversified in appearance, if not in origin. The process delivered consistency in a world once governed by volatility. Stability replaced uncertainty, and stability felt like security. But slowing chemistry carries consequences. Reactions do not disappear when delayed. They persist quietly. Nutrients shift. Molecular structures change gradually. Subtle transformations continue beneath the surface, altering food in ways not immediately visible or measurable. Preservation preserved form, but not always function. This is where early tension emerged. Preservation optimized for longevity, not vitality. Food remained edible, but chemically altered. Vitamins degraded slowly. Complex compounds diminished. Freshness became an appearance rather than a condition. The signals that once told the body what it was consuming began to blur. Producers adapted faster than biology. Systems optimized for storage, transport, and predictability replaced systems optimized for immediacy. Chemistry rewarded scale over proximity. The invisible process became foundational, quietly dictating what food could be and how far it could travel before being eaten. Convenience became the dominant metric. Eating was no longer governed primarily by seasons or location. It was governed by chemistry's ability to slow time, one reaction at a time. Meals became detached from environment and increasingly detached from effort. Consumption replaced participation. The conflict deepened as long-term effects became harder to ignore. Food systems built around preservation began drifting away from human biology. What kept food stable did not necessarily keep it aligned with nutritional needs. The body evolved alongside fresh, variable food, not uniform, time-stretched products. As reactions slowed, so did feedback. Taste adapted. Expectations shifted. Foods engineered to last longer lost some of the subtle signals that once guided appetite and satisfaction. Texture, aroma, and complexity flattened. Chemistry extended shelf life, but it also reshaped how bodies interacted with meals. Scientists studying nutrition began noticing a troubling pattern. Calories remained abundant, but complexity faded. Micronutrients declined. Chemical diversity narrowed. The same process that protected food from decay also stripped away compounds evolved to support long-term health. Eating remained sufficient, but less informative to the body. This buildup carried emotional weight because the change was invisible. Nothing looked broken. Stores remained full. Meals tasted acceptable. Hunger declined in many places. Yet chemistry had quietly altered the relationship between humans and nourishment. People ate more reliably, but not always more meaningfully. Attempts to correct course introduced additional layers of chemistry. Fortification added nutrients back in isolated form. Additives restored flavor and texture. Each intervention addressed symptoms without reversing the underlying shift. Preservation had become the foundation, and everything else adjusted around it rather than questioning it. This marked the emotional peak. The realization that feeding humanity had become a chemical balancing act. Longevity versus vitality. Scale versus nutrition. Convenience versus biological alignment. The invisible process had solved one problem so well that it created another no one had planned for. The invisible process had succeeded beyond expectation. It reduced hunger, stabilized supply, and supported population growth, but also rewrote how food supported life, one delayed reaction at a time. Chemistry had quietly become the architect of diet. The climax arrives with a quiet understanding. Chemistry did not change how humans eat overnight. It changed it gradually by stretching time itself. Preservation solved a real problem. It protected food from decay and people from starvation. But by slowing natural reactions, it also altered what nourishment meant. Eating became reliable, abundant, and increasingly detached from immediacy. Chemistry replaced seasons with systems. The resolution lies in awareness rather than rejection. Preservation is not the enemy. It is a tool. When combined with freshness, diversity, and biological understanding, it supports life instead of reshaping it blindly. Balance, not reversal, becomes a goal. Today, food chemistry is being reconsidered. Faster distribution, shorter storage cycles, methods that protect nutrients as carefully as they prevent spoilage. The goal is not to undo progress, but to rebalance it so longevity and vitality coexist rather than compete. This story reminds us that chemistry always solves the problem we ask it to solve. If we ask only for longevity, it delivers longevity. If we ask for nourishment, resilience, and health, it can deliver those too. What changed how humans eat was not a single invention, but a choice repeated at scale. A decision to slow one reaction without fully considering the others it would affect. Sometimes the smallest shift in perspective becomes the beginning of a new future.